But most people learn from their mistakes, and I just keep going back to Janet. You're coming to see her. Maybe she keeps doing a bad job, so I'll stop going to her, and I'm just not picking up on it. Okay. Okay, ready, James. Okay, the more we get done now, the less you have to get done later. So, what are we finding? How fast is the volume, Wilson? Chris. Okay, you're finding dVdt. What's my when? R equals 10. Then my given, it says the radius is increasing at a rate of 2. That's drdt. Okay, then from there, your equation is given to you. Okay, remember that for your CBA and the AP test, okay, you have to know basic two-dimensional shapes, but volume, surface area, usually they'll give you. Okay, so equation, take the derivative. What is the derivative of V? Okay, dVdt equals? Okay, 4 pi r squared what? Okay, very good. Then from there, you're just plugging stuff in. dVdt is what we're finding. So I'd have 4 pi r is 10. And then drdt was given to be 2. Okay. So 10 squared gives me 100. 100 times 2 is? Times 4 is?
800 pi.
Perfect. Okay, answer A. Okay, the other one that we're going to do is number 16. It's the very last question. Number 15 I did during 4th period, so if you want to go back and watch that video for that one, you can. It's at the very end. No, you should have been looking.
I was. I didn't. My pen ran out.
Oh, is that what y'all were talking about? Did it really run out of ink, Krish?
It's literally full.
Yes, I just couldn't go.
You refilled it? You refilled your pen with ink. That's your story. Okay, ready? Next page.
Wait, are you going to like do it by ourselves and then like?
No, you had it over the. Okay, maybe you didn't have it over the weekend, but you were supposed to have it over the weekend.
You didn't give it
Tell
to
us. Wait, so are we gonna do it by ourselves?
Yeah, over the weekend. I mean, it's rewind time and then go back to the weekend and then do it over the weekend. Okay, find,
What?
given, when. Literally every other class I gave it to, so I might have forgotten. Did I forget? Okay. I'll give you a separate blank one to do at home by yourself. Okay, it says the positive variables P and C change with respect to time. The relationship between P and C is given by, boom, there's your equation. Okay, then it says when dPdt is 41, and then it says that C is 15. Okay, then it says what is the value of dCdt? Okay, so take a look at your equation. What is the derivative? Okay, 2p dPdt. Other side, okay, it's not like a regular volume equation, but we can still take the derivative. What rule will that require, though? Chain rule. So my 3 is going to come down to the front. What's the new power on 20 minus c, my core? Squared. What's the derivative of the middle? Negative 1 dCdt. Very good. Okay, so think about why. Okay, the 3 comes down, I change it to a squared. Then I multiply by the derivative of the middle is a negative 1, and then I attach a dCdt. Okay? Now, from there, I'm going to rewrite it one more time. I don't like this negative here, so I'm going to multiply it with the 3. So really, 2b dPdt equals negative 3, 20 minus c squared dCdt. Okay, and I'm just going to combine the 3 and the negative 1 just to make it look less complicated. Okay, now, before I start plugging in, let's make sure we have everything. Okay, 2p, do I know p? So I'm going to leave a little space for it. Do I know dPdt? What is it? 41. Negative 3. 20 minus, what's my C value? 15 squared, and then dCdt I'm not supposed to know, because that's what I'm trying to solve for in the first place. The problem, though, is that this P, I can't just leave that blank. Where do you go to find a missing piece? The original. So I'm going to come back up to here. I know C is 15. Well, then can I find P? Yeah. So I'll do that over here to this side. I need P, so use original. Okay? We need P, so we're going back to the original. So I'm going to come back right here. It says P squared equals. Okay, then it was 20 minus 15 is my C cubed. Okay, well, what's 20 minus 15? 5. What is 5 cubed? 125. And then I can square root both sides. Okay, and 125 is not a perfect root. So one more time, we went back to the original equation. We plugged in our C as 15. And then we're just trying to figure out what to put here for P. Does that make sense? So my P is root 125. Okay, you can put that right here. Now, 2 times 41, that's easy. What's that? So I have 82 root 125. Okay, then on this side, let's work it down. We have 20 minus 15. How much is that?
Negative 75.
Okay, so one step at a time, that gives me 5. Then I square it, I get 25. Then I times by 3, that's where the 75 is coming from. Okay? Then from there, what do I do with the negative 75? Okay, divide it to the other side. So I have 82 root 125 over negative 75. Now, at that point, look at your answers. Is one of them that? No. Look at all your square roots, though. What do all the square roots have inside it? 5. That means that you need to simplify this. Now, I will say that most of the time on the AP test, they don't make you simplify these. But if it's 125, what perfect square is inside that? 25 times 5. And then what's the square root of 25? 5 root 5. So I'm going to reduce that to be 82, 5 root 5 over 75. And now you should be able to pick your answer after reducing. 5 and 75 can reduce to a 1 over, what would that reduce to? 15, yeah. So I can reduce that to be 82 root 5 over 15. Okay? Oh, and then negative, thank you. So that would be answer choice D. Okay? Now, I will also just give you a heads up. One of the related rates is a ladder problem. We did like 9,000 of those. So if you want to put a little note to yourself, one of the 3 related rates is a ladder. That you should know. Yes. Okay, all right. All right, let's do a little implicit. Go to number 11, or number 12. You remember these guys? Okay, what is the derivative of y cubed? Oh wait, no, I did 12 and 4th. Let's do 13 then. They're like similar. Let's do 13. Okay, what's the derivative of x squared? 2x. What is the derivative of xy? Product rule. Okay? So my u is going to be just the x by itself. My v is going to be the y. What's the derivative of just an x? 1. What's the derivative of just a y? dy dx. Now, real quick, some of you I heard saying like dx dt. Look at the base here. What's that letter on the bottom? X. That means I'm not doing the dt stuff, right? Okay, I get to, if it's an x, I get to just take the regular derivative. So, The bottom letter here is an X, not a T, so it's not a related rate. That's your hint there. Okay, so it'll be 1y plus x dy dx. Plus 1y plus x dy dx. Okay, then on the next term, I had a y cubed. What's the derivative of y cubed here? 3y squared dy dx. Okay, then from there equal to, what's the derivative of 0?
0.
Still 0. What can I move across that does not have a dy dx?
2x plus 1.
When they move over, they're both going to turn negative. So my dy dx comes out to the front. I have an x plus 3y squared left over. And then my 2x plus y is now a negative 2x and a negative 1y. Then your last step, remember that x plus 3y squared, you're just going to divide that onto the bottom. So it'll be dy dx equals negative 2x minus 1y over x plus 3y squared. Now, when I look at my answer choices, I don't see that. But what answer choice is equivalent? A. What did they do on A that I didn't do here? Yeah, they just took this negative from the top, GCF a negative 1 out front. Okay, and so if I do that, I have a negative out front, 2x plus y over x plus 3y squared. That's the same as answer A. Okay. So if I take that GCF of negative 1 out of the top and I put it in the front, okay, then my answer is the same as A. So go down to letter B. What if I want a horizontal tangent? What do I set equal to 0? Top. What if I wanted it to be vertical? Okay, good. So top equal to 0. So the top was a 2x plus y. I'm going to solve for x or y, but which one will be easier? I would probably solve for y because I don't want to have a half in it. So my y is going to equal a minus 2x. Now keep in mind that if you had solved backwards, that's fine. You're just going to have a 1/2. Okay, from here, where do I sub into the original? Okay, sub into the original equation. So my original equation was x squared plus xy plus y cubed equals 0. Well, then what will I get when I sub that y out? So it'll be x squared plus x. Bam, y is now a 2x. Y is now a negative 2x. Okay, so that's coming in to that guy. Now, what is x times negative 2x? Negative 2x squared. What is negative 2x when I cube it? Cube both, the 2 and the x. Negative 8x cubed. Okay, then from there, my first two guys are both squared, so that makes them combinable. They're like terms. What is 1x squared if I take away 2x squareds? Negative 1x squared, right? Okay, now from there, the only way for me to solve that is by factoring. So what can I take out of both of those two terms? Okay, and x squared, I'm also going to pull, yeah, I think I'll pull the negative out too. So negative 1x squared comes out, and then what's left over? Negative 1x squared, if I take the whole thing out, I have to leave a 1 as a placeholder. And then negative 8 divided by negative 1 is a plus 8, and then an x left over. So if an x was left in the front, what's my first solution? 0. So I know I need a 0 in my answer choice. Then out of the second two, if you don't like that order, make it an 8x plus 1. It's the same thing. It doesn't matter. So if it's 1 plus 8x, that's the same as 8x plus 1. What fraction do I want? An eighth or negative an eighth or negative 8? Negative an eighth. So it has to be that one. B. Yes?
That's what vertical tangent we use the denominator.
Yes. His question was, if it asks for a vertical tangent, you set the bottom equal to 0. That happens on number 12. So if you want to go to number 12 for me, okay, I'll go ahead and put a little mark on it. Am I okay to turn this page? Okay, number 12, when it says vertical or undefined, I'm going to set the bottom equal to 0.
What does V mean?
Okay, do we want to do one more of these?
Sure.
Okay, so take a look at it. What's the derivative of y cubed? 3y squared dy dx. What do I need to do with the minus xy? Product rule. Make sure you have to put the negative somewhere. So I'm going to let my u be a negative x, my v be a y. So what is u prime?
Negative 1.
Negative 1. What's v prime?
dy
dy
dx.
dx. Remember, the derivative of y is just a 1, but then I put the dy dx behind it. Okay, from there, my product rule is going to be one diagonal plus the other. So it's a negative 1y minus an x dy dx equal to 16? 0. Remember that if it's a constant, when you take the derivative, it goes to 0. Then from there, my 1y has to move over. It was negative, so now it's a positive 1y. The remaining two terms both have a dy dx. So I have a 3y squared minus x left over. And then, oops, I wrote that kind of weird. Okay, and then from there, where does this 3y squared minus x belong? On the bottom. So I'd have a 3y squared minus x. And then don't forget to cross it out. So your dy dx from part A is a 1y over 3y squared minus x. Now, that is your slope at any point. So in part B, they tell me the specific point that they want me to use. Find the slope of the curve at the point where y is 1. Now, can I plug into this if I only know y? No. How do you go back and find x using the original? So I would let y equal 1, plug back into the original. Y cubed minus xy equals 16. And then plug that in. So if it was a y cubed, now it's a 1 cubed. That's just a 1. Minus xy is x times 1, which is just an x, equal to 16. Then I'd minus that 1 across. What's 16 minus 1? So negative x is 15, then what's x? Yeah, just divide by negative 1 on both sides, it's minus 15. Now, keep in mind your notation. Do you remember the line thing when you're labeling? So you'll do dy dx line, and then you'll put negative 15 as your x, 1 is your y. Now, the other thing I'll tell you is your CBA is all multiple choice, so I'm not going to check your labels at all. I'll remind you of that tomorrow, but if you lost a bunch of points on your other tests, the CBAs are just scanned through for the district. Okay? Alright, from there, I'm going to have dy dx equals 1y, that's 1 times 1, over 3 times y squared, minus negative 15. Well, 1 times 1 on top is just a 1. And then if it's a minus a negative here, that's really a 3 plus 15. 1 over 18. Okay? And I already kind of reminded you how to do part C. So are we good with skipping that?
Yeah.
Alright, next one. Let's take a look at number... Let's see, first and second derivative test. Let's do number 6. Number 6. Am I doing a first or a second derivative test on number 6?
First.
How do you know first? Increasing. What if it had talked about concavity? Second derivative test. Okay, well, you'll hopefully remember it soon. Okay, so we're doing a first derivative test. That tells me whether f is increasing or decreasing. So in order for me to take the derivative of that, what rule do I need? Chain and product. So my u is going to be x squared minus 3. My v is e to the negative x. Now, the other thing I want to point out to you, what's the only letter in this equation? So no dy dx's, nothing weird, just a regular derivative. Okay, what is u prime if u is x squared minus 3? What is v prime, chain rule? It'd be e to the negative x times what derivative? Negative 1. Now, I'm going to put the negative 1 in the front, but where does that come from? That's the derivative of the core exponent. So if it's a negative x, the derivative of that is a negative 1. Okay, let's write our derivative. So f prime equals, yes?
Will you be able to use derivative?
You will get to use your derivative sheet and your cheat sheets. So just remember to bring that with you and you can use it. Okay, so like all of your colored sheets that we've made, you can use those. Okay, so let's write our derivative. It's going to be x squared minus 3 times negative e to the negative x plus, then other diagonal is 2x, and then e to the negative x. Now, after I take the derivative, what do I set it equal to? To find my critical numbers? 0. What can I take out of both of those guys that they both have in common? E to the negative x. So I'm going to GCF that out to the front. And then I'm going to put whatever's left over all in one big bracket. Yes, ma'am? I'm going to take the negative out in the next step, but most people, I think, wouldn't recognize that right away, so that's why I'm leaving it in for one more step. Okay, my e to the negative x comes out. What is left over from the first term? And a negative 1. Don't forget that, as Anusha said, you could pull the negative out in that first step, okay, but since I didn't see it in common, I'm leaving it right now. So my negative 1 has to stay, x squared minus 3 also stays, plus a 2x from the second. And then remember, I got to distribute that minus 1 into those first two little guys. So what are my signs in there now? It's a negative x squared, a plus 3, and a plus 2x. E to the negative x on the outside. Now, question, how am I going to break down that parentheses? I need to factor. Can you factor with a negative in the front? No. So even though I initially left that negative 1 in, I'm going to have to pull it out now. So I'll have a negative 1 e to the negative x. Now this is a positive x squared. I'm going to also reorder these. Should 3 come next? 2x should come next. And now it's negative, and then 3 comes third. Now, how can I break that down? Needs to multiply to negative 3 and add to negative 2. X minus 3 and x plus 1. So what are my critical numbers? Good. So my critical numbers on my line chart are going to be x equals 3 and negative 1. Now, why doesn't e get a critical number? Does e ever touch 0? No, it has an asymptote. It gets closer and closer and closer, but it never gets there. Okay, let's pick a number bigger than 3. What can we pick? 4. What's 4 plus 1, positive or negative? 4 plus 1 is positive. What about 4 minus 3? Positive. What about e to the anything? Positive, but then what do I have in the front? Negative 1. So I have a positive times a positive times a positive times a negative 1. Negative. Between the two, what could I pick? 0. Okay, what's 0 plus 1? Positive. What's 0 minus 3? What's e to the 0? And then times a negative. Hold on. It was a plus, a minus, and then another minus. Positive in the middle. Okay, because my two negatives eliminate each other when I'm multiplying. Okay, now another question here. Was negative 1 a double root? Then do I know it's going to switch sign? So if it's plus here, what does it have to be here? Negative. So remember, as long as it's not a double root, I know it's going to change sign anyway. So my function would have been decreasing, increasing, decreasing. Then on what interval is f increasing for? Negative 1 to 3. Answer choice D.
Wait, how does negative 1 and e to negative x cancel out?
They don't cancel out. I was plugging in 0 for that. So if I do 0 plus 1, that's positive. 0 minus 3 is negative. This negative times that negative, the signs cancel out. E is always positive. So you can almost basically ignore it.
Okay.
Also think about what's e to the 0? 1. So it's positive. Okay?
Good afternoon.
Oh, I thought it was one of your phones. I was like, alright guys, turn it off.
We would like to announce the proud winners of the Sweet and Savory Cook-Off.
What?
Please say
Some
your applause
teacher
to the left
thing.
so that everyone can hear the name.
No.
Congratulations, Jana Anderson, Keisha Hack,
Who's that?
Cheryl Latham,
Who's that?
She's a sped teacher.
Who's that?
She's a special ed
Marlon
teacher.
Taylor,
Miss Latham.
Miss Taylor.
She's the
and
office lady.
Jennifer Rayford.
Who's that?
Math
Do you
teacher.
have any of these teachers or know these people?
Congratulations, Miss
They can
Gardner.
cook.
You know,
They
but-
suggest you go by
I didn't enter anything, so...
Bring you a sweet or savory treat for Christmas. Have a fantastic day, Bergner.
Okay, huh?
Is that what they said? They get fruit.
I don't know. Let's do 7 and 8, because they look confusing, but they're not. Look at number 7. I want to know when f is decreasing. Is that a first or a second derivative test? First. Now, look at that function. What rule would we need if we had to take the derivative of that? Quotient. Do you have to take the derivative of it, though? Why not? It's already f prime. Very good. So I'm not taking the derivative of that. They gave me the derivative. So f prime of x equals, let's factor the top of it. 4 minus x squared is a difference of perfect squares. Square root of 4 is 2. Square root of x squared is x. So it's a 2 plus x. 2 minus x. Now notice it's kind of in a weird order, right? But it's still factorable. Okay, from there, what are my critical numbers? Okay, so my 2 plus x gives me a negative 2. My 2 minus x gives me a regular 2. What about the one from the bottom? That gives me a 2 again. It's already on the list. I don't have to write it again. Okay, set up your number line.
Wait, so we don't cancel that?
You can't cancel out if one of them's inside absolute values. That's a good question. You can't do that. Okay, now from here, when I plug in, how is the top always going to come out? Okay, very good. The top of this guy is going to be always positive. I don't care what I plug into the middle of it, it's going to come out positive. So if I'm plugging in, I really only need to check the bottom. So bigger than 2, maybe I pick 3. What's 3 minus 2? Positive. Divide it with a positive. Okay, between negative 2 and 2, maybe I pick 0. What's 0 minus 2? Negative. Divide it with something that's positive. Okay, then the far left subinterval, negative 2, smaller than that, maybe negative 3. Negative 3 minus 2 more is negative. How's the top, though? And a positive divided by a negative stays negative. So my graph would have been decreasing, decreasing, increasing. So where is my graph decreasing? To 2, answer choice A. Now look down at the next one. Very similar, looks a little different. First question I have though, am I going to need to take the derivative? No, it's already f prime. So all that I need to do is set that equal to 0. Okay? So I'm just taking the equation, they already gave me the derivative, and I'm setting it equal to 0. Then from there, what are my critical numbers? 2, negative 3. Now let's talk about G. G might have a critical number in it, but what do they tell us about it? It's always less than 0. Then does it give me a critical number? Critical numbers have to be equal to 0. So if it's always less than 0, no critical numbers for G. Okay? Then from there, set up your line chart.
Well, you said critical numbers have to be. Oh.
Critical numbers are where it's equal to 0. So since they tell me g is less than 0, I know it never touches 0. Okay, from there, take a look at your sign chart. Let's plug in 3. So 3 would be my test point for this interval. What is 3 minus 2? Positive. What is anything squared? Positive. And what is g of x? Less than 0 means it's negative. So 3 minus 2 was positive. The squared crap was positive. But g was negative. What's the sign on that interval? Which means g was decreasing. Okay, to the left of 2. Okay, let's say we pick 1. Plugging in a 1 here, what's 1 minus 2? Negative. What's any crap squared? Positive. What's g of x? Always negative. So if I have a negative times a positive times another negative, how's it come out? Positive. Also, was it a double root?
Yeah, so
Not 2 wasn't. Look at 2, it's chilling. What was the squared on?
x plus 3, so
3.
that will be positive.
So that means this side has to stay positive.
You're talking to him, not me.
Did you say that to me?
No, I was like, Kurt.
Nah, he's talking to you.
Impeach him! Impeach him! Okay, so increase, increase. Okay, look at your answer choices. What happens at 2? Max or min? Max. Okay, so then one more time. How did I know there'd be no sign change at negative 3 because of the squared? Okay, a squared means a double root. A double root means no sign change. So it would have to be A. Good? Okay. Alright, we have like 7 more minutes. Let's do a couple G prime graphs. Look at your first page. Okay, the last thing on your test is graphs of derivatives. We'll do number 2. Okay, it says you have a picture of a graph. What is this a graph of? F prime. So remember, this is not F. This is F prime. Says, when does F have a relative max? Okay, well, F will have a relative max when F prime changes which direction? Plus to negative. So put dots on your critical numbers. Remember, they'll be on the x-axis. What type of critical numbers? Negative 2. That's a min. What type is 1? Min, max, or neither? That's a neither. And then what type is 4? So if I want the max, I want 4. Okay, why? Because that's not F, that's F prime. Okay, second question, using the graph above, where does F have a point of inflection? Okay, points of inflection occur when F double prime changes sign. But if this is F prime, what is F double prime? The slope. So put X's on the graph everywhere that the slope changes sign. 1, 2, 3. Okay, each of those X's represent the slope changing from either an increasing value to decreasing or backwards. So X equals negative 1, positive 1, and 3. Because F double prime, the slope of F prime changes sign. It doesn't, but I want you to know. Okay, last part says, suppose this is a v of t graph, which is velocity. Where would the speed be increasing? What has to be the same sign for speed? Okay, v of t and a of t. So if this is a v of t graph, what would acceleration be? Slope. Now, some of you guys that are correcting your test realized you missed this question, okay, for a silly reason. Matching signs means both plus or both minus. So where on your graph of velocity, remember we're calling it velocity, do I have a positive velocity and a positive acceleration? What would I be looking for? Okay, a y value has to be positive and a slope has to be positive. That'd be here and here, yeah? But then where am I below with a negative slope? That counts too.
4 to 5.
4 to 5. Okay? Good job. Yep. You were not alone. Okay? Alright, we have 6 more minutes. You want to glance through it and pick 1 or 2 more?
Yes.
3? Okay. May I turn the page? Are you good? Okay, number 3. Okay, it says, I want f prime, and f double prime to all be negative, but I want my answer choice to be a graph of f. These are regular f of x's. Are they f primes? They're regular f of x. So let's talk about what each of those should mean. If f of x is negative, where should my graph be? Okay, it should be below the x-axis. Which graph is not below the x-axis the whole time? E. Okay, second part, f prime has to be negative. What does that tell me? F prime means the slope is negative. So look at your graph. Which of those graphs does not have an always negative slope? Okay, A and C, both of them, good. Okay, C is uphill the whole time. F prime of x then is greater than 0. That's not what I want. And then A, that part is increasing, so that's not what I want either. So I have 2 more left. What does it mean for f double prime to be negative? Concave down. Very good. And which of those graphs is not always concave down? D is not. This part here counts as concave up. So I'd have to choose B. So just make sure when you have a chart that you look at what it is. These are F graphs, so you have to kind of keep that in your mind. Okay, somebody said 4. Look carefully at 4. What are those graphs of? F, G, and H? Prime. This is F prime. This is G prime. This is H prime. So the question says, which one has a relative max on the interval? Well, where is a max going to happen if I'm looking at the derivatives? On the x-axis, yeah? So look at your first graph. What type of extrema is this first little point where it touches? Okay, that's a neither. What type is that one? Min. But what type is the third one? Max. So did it have a max? Check. Look at the second graph. Does it touch the x-axis? Yeah, right here at the origin, but is it a min or a max? That's a min. Because how does it change from negative to positive? Then did it have a max? No, don't want it. Last graph, does it have any critical numbers? Okay, this has no critical numbers. That means that it has no mins or maxes, so I don't want that one either. Then it'd be F only. Okay, second little question says, how many points of inflection does F have? Okay, I'll do a quick little sketch here of the graph. Where are my points of inflection if this is F prime? At the slope changing sign, which would be where? 1, 2, 3. Yeah? Okay, or some of you will say the points of inflection are the mins and maxes on F prime. That's perfect. Okay, then last question says, for which functions is the original function concave up at A? Okay, now, is this the original function? No, this is the derivative. So, for it to be concave up, I need the slope to be positive at A. So, look at your first graph. A is here. Is my slope positive at that point? Yes, then it is concave up for F. What about for G? Look at A. What's my slope? Okay, it's going downhill, so is it going to be concave up there? No. What about the last one at A? Okay, I see a positive slope. That means the original graph would have had to be concave up as well. Make sense? Okay, bell's about to ring. I'll send you the key for this. If you need help in the morning, I'll be here at 8:30. Okay, also we have a room change tomorrow, but I'll send it to you. Good job. Drop forms are due Friday. If you don't turn it in, you don't drop. Booyah.
I wasn't here for that. Can I have the quiz?
And then remember your quiz is due Wednesday.
Can I do the sheets?
for
Wait,
tomorrow.
what?
You could use
Wait,
the
what?
quiz from Friday.
Wait, it was the cold, bro?
Oh, you don't listen to them.
Jake, you want 3 M&Ms? Or 4?
Cause I listened to one and I tried to turn about linearizing graph.
What did you do today?
Tomorrow's
Was it hard? Wait, formal coffee was that, bro?
well, the quiz you get to take.
How much?
Good job. Thank you.
You get it? So it should be perfect. Because there's a possibility so you can pull it down.
Dang. You know he
I actually did today, and then my second period and told me he thought it was due Wednesday, and I was like, oh,
Exactly, right,
it's due Wednesday.
He said he don't care.
And then I realized I meant
How my high beat? Cause I'm on CBA. Okay, you have on sauce boys. You have on sauce boys for life.
Sauce boys for life.
Wait, do you have like
Wait, what'd you say now?
We're not due till Wednesday.
Wait, what today? What happened today anyways?
Hey, sauce boys for life, bro.
Hey, we
Working on it and you're random how
We have a CBA tomorrow.
So everyone
What the hell are you doing the reviews for?
Chris, Brooke.
All of y'all.
Let's push the CBA, yeah.
If I push it back though, then y'all aren't gonna work on this semester exam review tomorrow.
I would pass it.
Wilson already said he worked with
Huh?
Wilson already said he'd rather work with reviews.
And you kinda what?
I really kind of sound like you.
I know, we do sound like twins.
You know, like scream my voice.
You got a smoker voice.